Okay, so this is day one of logarithmic functions. So our essential question is, how is a logarithmic function related to an exponential function? And your objectives are on the side. Oops. So the definition of a logarithmic function, you got an introduction to this in Algebra 2, but a logarithmic function is a function with base b, and it's the inverse of an exponential function. So it's the inverse of an exponential. So it undoes an exponential function. All right, so just like an exponential has a base, a logarithm has a base. Its base is labeled with this little b at the bottom of it that tells me what the base of the exponential would have been. All right, and then it inputs. So we have a logarithmic function with base b. Your b must be greater than 0. So the base is usually, it's usually an integer, but not always. But it's got to be positive, and it can't be 0. And your input to a logarithm must be positive. The reason your input to a logarithm must be positive is because the output of every exponential is positive. Since the output of every exponential is positive, the input of every logarithm must be positive. All right, so the answer to a logarithm is what the exponent of the exponential would have been. So the exponent of the exponential is the answer to a logarithm. Okay, so we're going to change from logarithmic to exponential form. So I start by looking at my base. So on A, I see that I have a base of 5. So that's going to be the base of my exponential. And that base is raised to whatever the logarithm was equal to. So that becomes an exponent. And that equals, the exponential equals the input of the logarithm. So let's try that again. I start with the base of my logarithm, and it's to the power of what the logarithm was equal to. And that exponential equals the input of the logarithm. All right, so again, I start with the base of the logarithm, so 3. I raise it to what the logarithm is equal to. And that exponential equals the input of the logarithm. So go ahead and try the checkpoint on the next page. Please pause the video right now, try them, and then hit play to check your answers. Okay, so you should have a base of 7, exponent of 3 equals x. Base of b, I don't know what just happened over there. 7 to the 3 equals x. On letter B, you have a base of b to the 2 equals 25. And on this one, you have 4 to the y equals 26. All right. Okay, so on these, if we want to write each equation in its equivalent logarithmic form, then the base of your exponent is going to be the base of your logarithm. So if I'm looking at the first one, it has a base of 12. And so I'm going to go ahead and have log base 12. The answer to the exponential is the input of a logarithm, and its answer is the exponent. On B, it has a base of b, so I have a log base b. The input of the logarithm is the answer to the exponential, and the exponent is the answer. Okay, so one more time. The base of the exponential is my logarithm. The input of the logarithm is the answer to the exponential, and its answer was the exponent. Now, log base e is one of our special bases that we usually represent with natural log. That's our natural log, so we can label that as ln. So go ahead and try the next 3 on the next page and pause the video until you've done those. And once you're done, go ahead and hit play to check your answers. Okay, so you should have tried these, and so now you're checking your answers. So I'm going to do them a little quickly. So log 2 of x equals 5. Log base b of 27 equals 3. Log base e of 33 equals y, or ln of 33 equals y. So check your answers, make any corrections where you need to. All right, now how do we evaluate them? We can use this concept of how they relate to exponentials to help us evaluate. And so if I say log base 2 of 16, I can then say 2 to what is 16? So I know that 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the 4th power is 16. Therefore, my answer to log base 2 of 16 is 4. If I have log base 7 of 1 over 49, I'm going to do the same idea. I'm going to say 7 to what value is 1 over 49? Well, I know that 49 is 7 squared. But it's in the denominator. And when it's in the denominator, I can bring it up as a negative exponent. So 7 to what power is 1 over 45? To the negative 2. So the answer to this logarithm is negative 2. All right, next one. 25 to what power is 5? Well, I know that 5 is the square root of 25. I know that 5 is the square root of 25. So in that case, how can I represent a square root as an exponent? Well, square roots, back to in algebra, we learned that square roots can be represented as fractional exponents. So since this is a square root, we write it as 1/2. So that means my answer to this logarithm is 1/2. All right. I'm going to do D down lower here so there's enough room for all of them. So on D, this one I'm saying the 5th root, my base is 2, so 2 to what power is the 5th root of 2? Well, this is a radical situation. And so radicals we can rewrite as fractional exponents. And since this one isn't a square root, it's a 5th root, you always put the index of your radical in the denominator of the fraction. So in this case, my answer is 1/5. So go ahead and try the next set of problems, pause the video, and hit play when you're ready to check your answers. All right. So now you should be hitting play because you've done this yourself, and now you're hitting play to check your answers. So my base of my exponent is 10, and 10 to something is 100. Well, I know that 100 is 10 squared. Therefore, my answer to my logarithm is 2. 5 to something is 1 over 125. Well, 125, that's 5 cubed. That's 5 times 5 times 5. So that's 1 over 5 cubed. But if it's in the denominator, I bring it up as a negative exponent. So the answer to this logarithm is -3. 36 is my base, so 36 to something is 6. Well, I know that 6 is the square root of 36. And I know that a square root I can rewrite as a fraction. So that's to the 1/2 power. That means the answer to this logarithm is 1/2. And on this one, 3 to something is the 7th root of 3. And so I'd say 3 to the x is 3 to the 1 over 7. The index of my radical goes in the denominator. And so my answer to this logarithm is 1 over 7. All right, and so a couple basic properties of logarithms. If the base and the input match, if the base of the logarithm and the input match, then your answer is 1. If the base and the input match, then your answer is 1 because you're undoing the exponential, and a base to the first power is just the base. Okay, so logarithm of a base and the input is the same. They would basically cancel each other out and be 1. Logarithm of 1, no matter what the base is, the logarithm of 1 is always 0. And that's because anything to the 0 power is 1. So the logarithm of any 1 is 0. All right, so these two are important. These two are very important basic properties to recognize, know, and you will use them even as you go higher up into calculus. So if I have a log base 7 of 7, well, notice that the base matches the input. So when they match, that's just 1. And that's because 7 to what power is 7? Well, 7 to the first power is 7. Okay, log base 5 of 1. No matter what it is, if your input is 1, the answer is 0. And that's because 5 to what exponent is 1? Well, 5 to the 0 power is 1. Okay, so go ahead and try the next two. Hit pause, try the next two. Hit play when you're ready to check your answers. All right, so you should be hitting play because you've gone ahead and checked your work. So first one is 1, the second one is 0. All right, so straightforward properties, but they are supported by if you rewrite them as exponentials as well. All right. So using inverse properties of logarithms, if a base of a logarithm and the base of the exponent matches, we're going to be able to, they're going to cancel each other out, basically. They're going to undo each other because they're inverse functions. Inverse functions undo each other. So if I have a log base b of x, the log base b and the b cancel, leaving you just with the exponent of x. If I have an exponential raised to a logarithm, as long as the bases match, the key thing on these is that your bases match. As long as the bases match, they cancel each other. So on this one, log base 4 of 4 to the 5th. The log base 4 and 4 are inverses, so they undo each other. When they undo each other, I'm left with that exponent of 5. 6 to the log base 6. Again, the bases match. So they undo each other, and I'm just left with the input of the logarithm 9. So go ahead and hit pause and try the next two problems. When you're done, hit play to check your answers. All right, so you should be checking your answers now. So your correct answers are 8 and 17. All right, and so that's it for today's video. You will go ahead and see a second video on graphing the next day.